Welcome to What's New in Android Testing. My name is Stephan Linzner, and I'm a developer programs engineer at Google. So what do I do at Google? I mostly work on testing frameworks for Android, and so I'm one of the authors of the Android testing support library. Me and basically our team, we're really trying to make Android testing an awesome experience going forward. And today I'm going to talk about of some of the next generation of Android testing tools which we've developed over the past year. So I'm going to talk a little bit about unit test support because everybody's talking about it and it's really, really awesome, as you will see. And the second part of the presentation will be about the Android testing support library, mostly about Android JUnit Runner and Espresso. So yeah, let's dive right into it. So who in this room has already used unit test support? Okay, that's quite a lot of people. So, and how do you like it? Do you just raise your hands if you like it? Okay, that's almost all of you, and that's actually what I thought. So unit test support is something pretty awesome and something that wasn't possible on Android before. Before on Android, if you wrote a unit test, it always needed to run on the device, and with this unit test support, you can actually run them on your local JVM, and they're blazing fast, and it will boost your productivity, and it will bring down your feedback cycles in the test to a bare minimum. So why did we need to do this? As I said, there was unit testing before, but the problem with the old approach was that it was slow, and that's actually not what you want. If you write tests, you want really, really fast feedback, and this is simply not possible if you run an instrumentation, because you need to build two APKs, you need to deploy those APKs to the device, and then you need to run your test, and this takes forever. This can take, depending on the size of your test suite, this can take up to maybe 5-6 minutes per run, and that's actually not what you want. So why was unit testing not possible before, and what actually changed? So if you've ever tried to run a unit test which was compiled against the local Android jar you compile against, you might have noticed that you get this weird exception, runtime stop. And the reason why you get this is because the Android jar that you compile against on your local host just contains stubs. There's no code. Every method basically just throws an exception. And so even though, even before unit test support, you could get around this and run on the local JVM using a mocking framework, it was really hard to do in some cases because, especially the setup with Gradle and the previous setup with Ant, was sort of always, it was always a hack more or less. Using unit test support is actually pretty straightforward. The only thing you have to do is you have to add two dependencies to your test compile configuration. First of all, you need JUnit as the framework who runs your test. And then secondly, you need Mockito as a mocking framework to mock calls into the Android jar. On top of that, we added another option to test options, which is called return default values true. So what this does is if that value is set to true, the generated jar does not throw exceptions anymore, but it returns default values, which is 0 or null. But the thing about this is we don't recommend you to use this because we want you to knowingly call into the Android framework. And the reason is very simple. So if you test a piece of code which has some dependencies on the Android framework, and you're going to set that setting to true, that method is going to return 0 or null. So it might happen that the test will actually pass, but as soon as you deploy this on a device, it will actually fail because you have flaky and unreliable tests which you've produced here. So if there's no need for it, please keep this false, which is the default. And also, if you write your test, every time you call in the framework, please set up stubbing for this. To give you a quick example on how this looks with the new unit test support, So this is actually an example with a dependency in the Android framework. So here we have a simple class under test. It has a dependency on the context, and all it does is it actually loads a hello world string from resources. So if you don't use Mockito, and if you don't use stubbing, and if you execute that test, it will fail because it will throw the stub exception. But now, with the unit test support, you can easily use Mockito. So what you can do, you can just create a mock context, you can inject the mock context in the class under test. And then more importantly, you can set up stubbing. You can say, okay, mock context, if you get a call on the get string method, then return our fake string. And now, if we actually call the get hello world string method, it will actually return this fake string, and we can then verify that the string is actually, that the get hello world string function actually returns the right value. And so you can not only do this for classes with Android dependencies, but for your normal cultures, like in the Java world, and yeah, it's really fast and it's pretty cool. In order to run these unit tests, it's pretty much the same thing like it is for instrumentation tests. There's one subtle difference I wanna point out at the bottom left. So basically, Android Studio has a limitation in that it can only have one active source set at a time. And so this is the same thing like with variants, right? You can't have two active variants at a time. And for testing, it's the same thing. If you write unit tests, you need to tell Android Studio that you're writing unit tests. And this is done, if you can just go to the build variants panel, and then you'll see there's a new setting for test artifact, and then you can just flip sources, flip the testing sources there. Why I mention it is because that's a common pitfall in the beginning, and if you don't do this, you will still see the code, but you don't have code completion, imports will not work, and so it just looks like it's a bug and it's acting weird, but it's actually not. You need to flip the source step. So as soon as you've done that, the only thing you need to do in Android Studio is to create a run configuration and then hit the play button at the top, and then hopefully all your tests will pass. You can also, of course, run the tests from the command line. So we actually have a new task in the Gradle plugin called test. You might already notice this task. And if you run that task, what it will do, it will compile your code, it will compile your test code, and it will use JUnit to run the tests. But more importantly, and that's why it's in bold here, is there's a new task called mockable Android jar, and this is actually how the unit test support works. So what that task does, on the first run per API level, it will create a mockable jar with stripped out finals, and also if you set the return default values to true, it will also return 0 or null. So, but don't worry, this is only done on the first test run, and every subsequent run is cached, and this makes for really, really fast feedback cycles and fast testing. The other thing I wanted to mention here is we recently made a big improvement to reporting, which is we now have actually two types of reports. We have our old HTML report, which you can see in the screenshot, but we also now have support for XML reports. And this is a pretty big deal because you can now take the raw output of your test and integrate it with your infrastructure. Let's say you can just display results in an easy way on your Jenkins build server or any other infrastructure you have. And another thing I want to point out at the top, I actually, in bold, I actually put the folders where these reports are located because at first, if you're not used to it, these locations are hard to find, so now you can always go back to this presentation. Even though unit test support is awesome and you really should start using it, right now there's some limitations to it. So one limitation is if you have tight coupling with the Android framework, then you will have a hard time mocking out all of the calls in the Android framework. And this is something that you really want to do, and I'm talking about solutions later. And the second thing that you have here is stubbing static methods. And I know this is a big pain point, but we're working on a solution. But the problem basically here is with a framework like Mockito, you cannot mock static methods. And so this is a big problem if you use static utils, which there are plenty of in the Android framework. In the code, you try to unit test. So how do you work around these issues? So the type coupling with the Android framework, I think so. Like the first instance is always go back to your code and revisit your design decisions, because what we see, most of these tests which have like a horrible 20-line mocking or at the beginning are actually classes which have a bad design. It's classes that don't follow object-oriented principles, that do more than one thing. And like the first thing might actually be try to think of refactoring your class, maybe in like 2 or 3 other classes, which makes sense, and then inject them as dependencies, and then you can write a unit test for each of those classes. And this will, you will still need to mock the calls in the Android framework, but the test becomes much more readable and maintainable. Because the other thing here, the problem is not that it's not worth doing. The problem is that you mess up your test code to a point where it's barely understandable, and if you get new members on the team, they will have a hard time following your test. And by revisiting your design, you will of course also improve your app as a whole. But there will still be cases as of now where, like, even if you refactor, you will still have a fair amount of calls into the Android framework. And in that case, right now, I would just recommend you to create an instrumentation test, a unit test which runs on instrumentation, and run it on a device or emulator. This isn't too bad because often this is just, like a single test. And it's fine to do it because it makes for a more clean test, and it will also save you a lot of time. Working around the static methods is a little bit more tricky. In general, there are 3 approaches to this. So the first thing is you can always wrap a static API in another interface, and then use that wrapper in the class as a dependency in your class. So I think this works well for something like log, where actually writing a wrapper makes sense, because it's something that you would do in production code anyways. But for things like text utils and other static utils in Android, it doesn't make sense to add all this boilerplate to your production code in a way you would never do it if you weren't for testing. And so in that case, what we recommend right now, before we have a better solution, is to use PowerMockito. And PowerMockito is it's based on PowerMock, and it's an extension to Mockito, and it allows you to stop static methods. And so this is a solution we recommend right now, but I want to warn you, don't use that as an excuse for bad design. Only do it if you really need to do it and have a static method you call in your production code in the Android jar, which you cannot easily get rid of. The third solution is return default values, but honestly, I don't recommend you to do this because we've played around with this internally, and we found this makes for very, very flaky tests. And if you have an unreliable and flaky test, it's even worse than having no test. One thing I want to mention here also is, it's not on the slides, but there's a community plugin called Unmock plugin, and what it does, it has a nice DSL, and it lets you overload classes on the class path for a unit test support, and it gets those classes from the Rogue Electric jar, and this is actually a great approach to this problem, and it might be similar to what we come up with. But right now, if these methods, if wrapper, PowerMockito, and return default values doesn't work for you, you can look at the Unmock plugin. And actually, like, the Unmock plugin also gives you something that this can give you. It's also possible, let's say you have a class which runs on a JVM, right? So you can just load that class and overload that class on the class path and use it. So yeah, let's talk about the Android testing support library next. We released this library in December last year, and it's an amazing new library which acts as a container for all the testing frameworks that we develop at Google. The Android testing support library is based on instrumentation tests, so it's mainly for tests that you actually run on your device. or emulator. These tests need an instrumentation runner to run, and we have a brand new one actually called Android JUnit Runner, which I'm going to talk about in a minute. And the tests for this are located in the Android test source set. So if you write one of those instrumentation tests for the support library, they need to go into Android test. Using the support library is actually pretty easy. So if you've used any other support library before, you know that you just need to go to the SDK manager, then scroll to the very bottom, and then you will see a checkbox where you can actually download the Android support repository. And if you download the latest version, you will automatically have all the artifacts from the Android testing support library installed on your local development machine. Using the support library is also easy. You just need to add two things to your, or 2 lines to your build.gradle file. So the first thing you need to do, of course, you need a dependency on the support library itself. And the second thing is you need to tell Gradle which test runner to use to actually run your test. And in the case of the support library, the new runner is called Android JUnit Runner. Running the tests, it's pretty much, it works pretty much the same as running the unit tests. The only thing you need to remember, as I said, is to flip the test source set in order to develop the tests and get all the Android Studio goodness. And then after that, again, you have to create a run configuration, hit the play button, and to run your tests. You can, of course, also run it from command line using the connected Android test task. And again, why I show the command line output is because it shows how this actually works internally. So if you execute the connected Android test task, what will happen is Gradle will first build the app under test, and after that it will actually create another APK which contains only your test code. Then it will deploy both of those APKs on your device, and then the test app will use instrumentation to control your app under test. And the reporting is also very similar. The only difference actually is that the reports live in a different folder, but I mentioned this before, and if you know where those reports are located, just look at the URLs at the top. So the next thing I want to talk about is Android JUnit Runner. Android JUnit Runner is something that we've worked on about 6 to 12 months now, and it's a new test runner for Android. And the most significant feature of it, or there are actually 2 significant features. One is that it's unbundled now, so this test runner is unbundled from the actual platform. And the other thing is it has JUnit 4 support, which makes for much more readable tests, and it's just a so much better API than JUnit 3, and you couldn't use it before, and now we enable you to use it. We have, of course, or I'm going to talk about instrumentation registry and test coding in a minute, but another feature that we recently added in 0.2, the new version, which will come out in a few days, is actually you can now do intent monitoring and stubbing in the runner. So if you actually write a test, you can monitor any intents that were sent to the system, and you can even stub results. And as we will see in the presentation, this is actually a really cool thing. The other thing we allow you to do in the runner is you can actually very closely monitor activity and application lifecycles. So even though you would mostly use this if you write your own framework, sometimes it's helpful. For example, if you want to, like in your test, figure out if your activity was actually finished, you can use the activity lifecycle to make an assertion on that and register on lifecycle monitor. So this is something that's actually pretty handy as well. But you normally wouldn't use it. So how does the new world look like? It's a lot cleaner, as you can see. The first thing that you might notice is we don't extend from test case anymore, right? Because before, if you had an instrumentation test, you were always extending test case or instrumentation test case or activity instrumentation test case. So this is gone now. The only thing that you need to do now is you need to annotate your test with the Android JUnit 4 annotation, and this will actually tell the runner that you want to run in JUnit 4 mode. And then everything else is pretty much the same, like you would use JUnit 4 in the Java world. So you would use an add before annotation to set up your test picture. So this is the equivalent to set up in the JUnit 3 world. Your tests now need to be annotated with tests, but the thing that you don't need to do anymore is you don't need to prefix your test with a test prefix anymore, which makes for great readability. And then, of course, you can use that after the equivalent to tear down in JUnit 3 world to release any resources that you might have allocated. You've already seen it on one of the slides before. We now have something called Instrumentation registry, and the reason for this is pretty simple, because in the previous world, in the JUnit 3 world, we always extended instrumentation test case or activity instrumentation test case too, and this actually gave us access to instrumentation. But because we don't extend those test cases anymore, you need to have a way in your test to access instrumentation, access the context of the instrumentation thread, and also access the context of the target app. And so this is now all done through Instrumentation registry. And another great thing about the registry is you can now also get the arts bundle. And this is really cool because it now allows you in your test at runtime parse the arguments that were actually passed to the runner. So you can pass custom arguments to the runner and have them available at runtime in your tests. The other thing that we've added are test filters, and we already use them heavily internally. So for now, we added two filters. One is SDK suppress, which allows you to suppress a test on certain API levels. So you just specify the min SDK version you want to run that test on. This is especially important if you want to keep clean tests. And the other annotation that we added is because what we found internally sometimes mostly we run on emulators, but sometimes tests can't run on an emulator and we want to run them on an actual device. And so now we have that annotation, and these tests are being suppressed while we run on an emulator, but as soon as we start using a device, these tests actually also run on the device. So just think about if you test interaction with camera or Bluetooth or anything which is hardware related and needs to run on the device. So the next thing I want to talk about is something that we actually haven't talked about before. It's something that will go into the next release of the support library. Looking back, we found that using activity instrumentation test case 2 was not a great solution, and now that it's not possible anymore, I mean there's some hacks you can still use it, but with JUnit 4 it's actually discouraged to use it. We actually decided to deprecate activity instrumentation test case 2, which is like great on one way because we all struggled with it and we all fought with it. On the other hand, it's something that we used for years, and so I'm happy it's there. But I think at the end of the day, we put a lot of thought in this, and we came up with a new solution, which is much better, which uses JUnit rules. And so now, starting with 0.2, we actually have something called activity test rule, and this is using JUnit 4 rules. And what you can actually see here is a side-by-side comparison in Gerrit, and on the left you actually see the old JUnit 3 rule, and on the right you see the new JUnit 4 rule with activity test rule. And I mean, you can notice just by looking at the diff that we removed a lot of boilerplate code because before you had to create this no-R constructor, and then you had to override the setup method. You had to explicitly create and launch the activity by calling getActivity, and now this becomes only one line of code. So let's look at a quick sample. So basically, the first thing you have to do if you want to use activity test rule is you have to use the rule annotation. So this will tell JUnit 4 that you actually want to run this rule for every single test. And the important thing to note here, a rule actually also runs before any add before methods, and it will also run after any add after methods, and it's the perfect mechanism to inject code and behavior, additional behavior in your tests. And so yeah, you use that rule annotation, and then you just create an instant of activity test rule, passing in your activity class, and then the magic happens. You don't have to have an before method. The activity is actually created for you, it is launched for you on the device, and you can do what you're best at, writing tests. And you can focus on writing the test code rather than boilerplate code. I just want to show this quickly because I would say in 90% of the cases you would just use this one-liner for activity test rule, but in some tests you need to access your activity, and you can do that by just calling the getActivity method on the test rule, and this will always return you the current activity instance. The other thing you might want to do in some rare cases is you want to override the intent which is used to actually start the activity in instrumentation. And then we also have other interceptor methods, but I think you will rarely use them. They're useful if you want to set up your global tests fixture, or make your test hermetic and flip some switches. But usually you wouldn't use them at all. So the other thing that we've added in 0.2 is something called service test rule, and service test rule is the equivalent to what we previously had with service test case. And service test rule works pretty much the same way that activity test rule does. You need to use the add rule annotation, and then you just create the service test rule. And what this will do for you, this will actually, you have actually two options of doing it. This will either start your service using an intent, or it will bind you to the service. But in either case, before your test runs, we make sure that your service is actually connected to your activity. The other thing to note here is, if you've ever used service test case, it's sort of like that weird thing where it's like a unit test, but it's not really a unit test because some things are still called in the system, so it's like this mixture between a unit test and an integration test. And we talked to a lot of engineers and partners and the community, and what we found is that most of the people actually don't use it because what they want is a real integration test, and this is exactly what a service test rule can give you. It can give you a real integration test, so the service is really started on the device. It's really bound to your activity under test, and you now can really test those interactions with service test rule. And this is just a start. These are just the two rules that we're going to add in 0.2, and we actually have a lot more rules coming out for the next 2 or 3 releases. And our goal is really to port all the functionality from the platform in the support library so that we can actually deprecate the platform APIs at one point. So the next thing I want to talk about is Espresso. Espresso is also part of the testing support library. And who has heard of Espresso, by the way? And who's using it, like on a daily basis? Okay, yeah, that's quite a few people. You should really use it. If you haven't used it, the first thing you do after this conference, or even in the hackathon, go try Espresso and write some unit tests. It is so much fun. It is so much fun writing them. You really can't stop. So what is Espresso? Espresso is a radically new approach to UI testing, and it is an API from developers for developers, right? It's really, when we spec'd out this API, we really sat down and we really thought, okay, what can we do to make developers that write UI tests like 1,000% more productive, right? And that's where Espresso came from. And, the main thing when we thought about it was actually, what would a user actually do with your app, and how can we make an API that's actually pretty close to that? So what would a user do? What are you doing? Like every day, if you look at your phone, just think about it. Like the first thing you do, let's say you want to book a hotel for Droidcon2015. The first thing you do is you probably open up a hotel booking app. But then the next step is, if the app is open, you will look you will actually look and try to find a view where you could actually search for a hotel. The next thing you will do is you will enter maybe hotel in Turin in that edit text field, and then you will click a button, which means you will perform an action. And then something's going on the network, the data is loaded, and then the UI state is changed and something is shown in the UI. And then, you of course check for results which are shown after you search. But it's basically what you do, right? If you think about it, every time you just try to find a view, you perform an action with a view, and then you verify some state change which resulted from the action. And so this is what we came up with. So, and this is most of the Espresso API, to be honest. So what you do in Espresso as a developer, you just say, okay, hello Espresso, find me the view with my view matcher. The next thing you do is you say, okay, now on that view, please perform an action for me. And then the last thing you do is you say, okay Espresso, now please check a view assertion, check that the state of the UI has actually changed. And this is all there really is to Espresso. And I'm not going into detail because this is not a talk about Espresso, but we have many possibilities for you to match views with the view matchers. We have many view actions you can use out of the box. I actually can't think of one that we don't support. We provide you with many view assertions you can use to verify UI state. And we took all of that and put it in something we call the Espresso cheat sheet, and it's actually something you can download under this link. It's also on our Android test kit page, and you can download that and really pin it to your wall. It will make your life so much easier. But let's look at how you would actually use that in your app in the hackathon tomorrow if you want to. So given that you've downloaded the support library already, all you need to do is you need to add the Espresso core artifact to your Android test compile configuration. And yeah, then you can start using Espresso in your test. And the next thing you do is you create a test. You start the activity under test using the activity test rule, which I showed you. And then in your test, you do exactly what a user would do. The first thing is you would find an edit text view. The next thing you do is you type in some text in the edit text view, close the keyboard, and then click on a button. And then the next thing you do is you observe some UI state, right? By checking if the text that's now displayed in the UI matches your string that you entered in the edit text field. And this is most of the Espresso API and how you would write tests. And of course, we have some more APIs. For example, we have an OnData API, which works exactly the same like the OnView API, but it's for adapter views. And the reason why we added this API is you could potentially use OnView to work with, an adapter view is a list view. You could potentially use OnView and a scroll action to work with adapter views, but it's a lot of boilerplate code. That's why we added OnData. And OnData actually does a very smart thing. It does find your view to the corresponding data that you specify, and that's actually a much better and more efficient approach. The other thing that we support is we have multi-window support. So for example, if you use an autocomplete text view or if you have dialog, they all live in different windows, so they have different view hierarchies. And Espresso actually knows about these different view hierarchies, and it allows you to switch between them. The other thing that we do, it's something that's not visible to you, but it's an amazing thing. We synchronize everything. We synchronize everything which runs on a UI thread. We synchronize everything for async tasks for you, and we also have an API if you use your own mechanism or thread pool, whatever, to do asynchronous calls. We have an API to tell Espresso when it's idle. And why is that important? Because 80% of the test flakiness in the old testing framework came from those type of timing issues. And I reckon anyone in that room who's ever written a UI test without Espresso or without volume support has put a thread sleep in their tests somewhere, right? And the reason why you do this is pretty simple, because you need to synchronize, because sometimes things take like 100 milliseconds longer, and so by the time you wanna verify that some view is on the screen, it's actually not on the screen, but you know, it works like 50 times, and for the 51st time it doesn't work. And this is what Espresso is great at. So we look at the looper message queue, and we can actually we know when the action is finished, and even within the next millisecond we execute the next action. And this is pretty awesome, because it not only makes tests more reliable, it also makes them faster by a magnitude of 5 or 6x. The other thing I wanted to mention, of course, beyond the core APIs, we have something called Espresso Culture. And Espresso Culture contains some convenience APIs for US developers to deal with common UI widgets. So one of the most, or 3 of the most popular are draw actions. So if you have a navigation drawer, we actually give you APIs where you can just like slide in and slide out your navigation drawer. We have recycle view support, and we also have things like, so let's say you use a date or time picker widget in your application. Espresso can also set a date to that, to the picker actions, which is for you, which is amazing. In order to use the contrib library, the one thing you have to do is you actually have to add another artifact to your build.gradle file, Espresso Culture. So, and with that, I'm talking about the last thing for today, and it's actually one of the things, I've talked about it before, but I'm really excited because we are very, very close to release it. It's called Espresso Intense, and this is the latest addition to the Espresso family. So what is Espresso Intense? Espresso Intense is a modeling framework for intents. So why is that important, you might ask yourself? It's important because it enables, for the first time, it enables you to do hermetic inter-app testing. And what does that mean, hermetic inter-app testing? It basically means that in your app, if you have any dependency on an external application, you now don't have to call that application anymore. You can just stay within your app. But let's look at a quick example. So let's say you've written that amazing app, and that amazing app allows users at one point in your UI flow to capture a picture, and it uses the Android native camera to do this. So the way you would implement this, you would have an open camera button, and then your user presses the open camera button, and then what will happen under the hood, it will create the intent with the camera action or with the take photo action. You would actually call start activity for result and pass in that intent to the system. The system would then start up the com.android camera process. The user would take a picture, and then the user will return to your app. And what happens under the hood is an activity result is sent back to your activity with a bundle of data which is containing, I think, the thumbnail and a URL to the full image on disk. And then, you can take that thumbnail and display it in your UI. If you want to UI test this, you have a little bit of a problem here, because as soon as you press the open camera button and the camera opens up, the camera runs under a different user in a different process. And instrumentation is not capable of testing outside of your process. And so as soon in your UI test, as soon as you click that button, you actually lose control and the test will fail. So one thing in your UI test, what you don't want to do, you don't want to test the Android camera app, right? The other thing you want to do is you want to test your UI. So you want to send the intent in your actual code, but you don't want to let the intent go down to the system. And this is exactly what Espresso Intents allows you to do. It has two APIs, one for intent validation, which means you can, in your UI test, you can just say, okay, you can exercise some UI code, and then you can say, okay, was an intent sent to a given package, and you have an intent matcher to very precisely specify that intent. And the other thing you can do, which is even more powerful, which we've just seen in the camera example, you could actually stop intents. So you can say, intending, there's an intent to a specific package with a specific action, whatever you specify in your intent matcher. Don't let it pass to the system, but respond with a fake result that you specify in your test. And to use Espresso Intents is as simple as using the other Espresso artifacts. You just need to add Espresso Intents to your build.graph file, and then you can start writing your tests. So let's look at a validation example. So again, we created a JUnit rule for you, intents test rule, to make it easier for you to use this API. So intents test rule extends activity test rule, and what it does is it actually inits Espresso before the test run, and it releases Espresso intents after the test run. And so you know, this is just boilerplate code you would need to every test, and that's why we again have a rule which make you be able to focus on your testing, and we do the heavy lifting in terms of setting up the test picture. And then in that case, what we do in that test is, so the first thing we tell Intenter is to stop all outgoing intents. So we say, intending, the intent is not an internal intent, always block it and return activity result. So by calling this line of code, if you actually press the camera button or go to any external package, it will actually immediately return. That's the first thing you do. The second thing you do is you exercise some UI, you write some UI tests using the beautiful Espresso APIs, and then in that case, what we do is there's an edit text field, you can type a number, and then there's a call button, and we actually press on that call button. And as soon as we press on that call button, we would usually start the dialer activity on the phone, but because we set up stubbing for external intents, it actually doesn't start the activity, but the intent is recorded. So now, the last thing we can do is we can just say, intended, there was an intent to the end of the dialer package with the action call and the number we specified, evaluate to true, right? And so we can just, in that case, we can just verify that the intent was actually sent without actually leaving our process and without actually losing control over our test. And this is really, really powerful because this could be done, but with a lot of boilerplate code and with additional abstraction layers. And now you don't need that anymore. You can just use Espresso Intents. And so this brings me to the end of my presentation, but I have one more thing I want to talk about is, please guys, if you care about these things, we're on this small team, please start contributing to the Android testing support library. I will make the slides available, and it's maybe too much to browse it now, but if you're interested in these things, please go back to the slides. I put all the instructions here, and with those instructions you can actually submit a patch to the Android testing support library maybe within 30 minutes, and please help us make this even more awesome experience. And the other thing I want to do at the end is I want to thank you all. I want to thank everybody in the community. We've been very, very grateful, and we've been so happy about receiving all the positive feedback. Like the whole team thanks you for your feedback, contributions, and everything you do. And when we launched Espresso, it was tremendous to see, because we just did the I think it was the second most successful post on Android developers, yeah, keep that coming, keep the feedback coming, and please contribute. And I think with that, yeah, we can wrap up and go into Q&A if we still have time.